So in the previous video we reached here, and I forgot to mention something in the first video, and that is that the sigma of the sum of some terms, let me show them by the figures, equals to the sum of their sigmas. So that would be equal to sigma of this plus sigma of this plus sigma of this. Okay, so here this would be equal to sigma. This sigma would be equal to sigma 1 plus sigma 9 over this term, and since it is constant in sigma, comes out that would be plus 9 over n squared times sigma I minus 1 squared plus the sigma of the last term, and again 6 over n is constant in that sigma, which means that as I changes, the n doesn't change. Okay, it comes out that would be 6 over n sigma I minus 1. Okay, now what is sigma 1? As I changes, now take the values 1, 2, 3, 4. This would be 1 plus 1. This is for I equals to 1. This is for I equals to 2. You know, here it doesn't got I. Okay, but what is it? So we got n ones corresponding to each I from I equals to 1 to n. So that would be n plus, how about this sigma? 9 over n squared sigma I squared plus 1 minus 2i, so which is sigma I squared plus sigma 1, which is n as here, minus or plus minus 2, or minus sigma 2i, or 2 is constant, so that would be minus 2 sigma I. Okay, now what was it? According to the formula I gave you in the first video, this is from I equals to 1 to I equals to n. I didn't write it here, so that would be n times n plus 1 to n plus 1 over 6 plus n minus, and this is according to another formula I gave you, is n times n plus 1 over 2. So the 2 goes by this, that would be n times n plus 1. You know, this n goes by this n, so we got minus n squared here. For this, and we got plus n here. Oh sorry, I did that. Okay, multiply by sorry, multiplied by this 9 over n squared. Now we got another thing here. Let's calculate it also. This is sigma I minus sigma 1. So let me write it, 6 over n times sigma I is n times n plus 1 over 2, and sigma 1 is n. So this n goes by this n and this n, that would be 1. And let's multiply it into this. That would be 3 here and 6 here. So this is 3n plus 3 minus 6 would be 3n minus 3. 3n minus 3. Okay. Or let's write it here. No, here. Outside the parentheses, 3n minus 3. Okay, now I'm not gonna calculate it, but calculate it all. But here we got 1, 2 n cubed after multiplying it. So this 2n cubed after dividing by 6 would be n cubed over 3, and after multiplying by this would be 3n. Okay, we got 3n here from it, and we got what happened, sorry. Okay, and we got another 3n here, 6n and 1n here. That would be 7n. Okay, 7n, and the whole thing should be multiplied by 3 over n. And 7n times 3 over n would be 21. So, but the rest of the terms, are in the minus degrees. They go to the denominators. For instance, here we got the big term here. The biggest term is 3, and the second, the degree of 2 or second after multiplying by this becomes a number, and after multiplying by this goes to denominator. So we got another terms which goes to denominator. I'm not gonna calculate them because it doesn't matter here. You see why that doesn't matter here soon. Okay, and this was the left Riemann sum, and the right Riemann sum also equals to 21 plus another terms, like in this form, but differs from this. Okay, and now let me and the area was between the right Riemann zone and the left Riemann zone. Okay, which is 21 plus another terms, say containing n. Let's write it like p n, and this equals to 21 plus another terms of n. Now the limit of this as n goes to infinity would be what? Would be 21 plus 0, because here the terms containing n's are in the denominators. So their limit as n goes to the infinity is 0, and the limit of this as n goes to infinity is 21, and the limit of this also equals to 21. Now, according to the squeeze theorem, which says if you got three functions or series or sequences in which one lie between another two and the limit of the other two be equal, as here the limit of this is 21 and the limit of this is also 21, then according to the squeeze theorem, the limit of a as n goes to infinity plus infinity would be equal to their limits also, would be 21. And a, what was a? A was a constant number, was the area under the parabola between 1 and 4 and above the x-axis, which is a constant number. So the limit of a constant number is itself, and then the area we were looking for would be equal to 21. And I'll talk more about that in the next video.